In this video, I want to talk about how to find a joint probability. This is very similar to the previous video. I'm just doing some more examples. So just like in the previous video, we have a joint probability and we're given the joint probability distribution function. We have this funky dependent support. So we're going to start, just like we did in the previous video, by drawing out that support. Okay, so you could write the support like this, or you can write it like this. It's basically two-step way of saying it, and this is basically a one-step way of saying it. Okay, so we have y is greater than -1, so it's above -1 at the same time, and x is greater than y. Okay, so x is greater than y. So we get this triangle area, and it goes onwards to infinity. Okay, so all right, so now we're trying to find this probability. Remember, the total probability, if you were to integrate over this entire support, is equal to 1. But now I'm just restricting myself to this area where x is greater than -3. Where x is greater than -3, I want to find the area of that little subset. Okay, so let me go ahead. I know that what I'm going to want to do is I'm going to want to integrate my joint probability distribution function with regards to x and y. Okay, so your order of integration, sometimes it's easier to do with y first and x second and vice versa. It actually doesn't matter if which order you do it in, as long as your bounds match that order, you should get the right answer. Okay, so really in this video, I'm only going to talk about how do we find these bounds. I'll leave the integration to you to do later, and if you have any questions, you can post about it and let me know. Okay, so how do we find these bounds? Where is x greater than 3y? Okay, so that's what we want to do. We want to graph this. Okay, it has to be also part of this yellow area. Okay, so let's see. First thing I'm going to do is I'm going to go ahead and write this as x equals 3y, just like how I graphed this line as x equals y, right? So I'm going to graph the equality, 1/3 x, or y equals 1/3 x. Now you remember your y equals mx plus b, right? This is the slope, the intercept is 0, so up 1 over 3. Okay, let me use a different color. Up 1 over 3. Here we go. There we go, down here. All right, now which side of this line should I shade? Is it above the line or is it below the line? You could use a test point. Say we use this point here, x equals 1, y equals 0. If this point is to be shaded, then the entire area is to be shaded. If it's not to be shaded, then the area above will need to be shaded. Okay, so let's do 1. X equals 1. Is 1 greater than 3 times 0? Is 1 greater than 0? Yes, it is. So it's all that's down below this line that we should be shading. Okay, now be careful. We should not be shading over here because we still need this relationship where x is greater than y. So still need that relationship, so I should respect that line. Okay, I need to stay in the yellow area. All right, and we go onwards to infinity. All right, so now I have this kind of awkward shape, and I need to talk about how to integrate over this shape. All right, so if I integrate with regards to y first, y goes from -1 until we get to x in this area. Once I get over here, it changes its rule. It goes from -1 until we get to 1/3 x. All right, so because it changed its rule, we're going to actually want to split this up into two different integrals. We'll do this first piece first. Okay, so y equals -1 till x. Okay, then what does x go to? X changes from -1 to 0. -1 to 0. And then I'll want to add that to the second piece. So I have this piece, and I want to add that to whatever I have over here. It's using the addition rule for integration. We can split up our integral like this. Okay, so now for the second piece, y goes from -1 to whatever this line is. So remember, y equals 1/3 x. So from -1 to 1/3 x. Okay, and then what does x go from? in this piece, x travels from 0 onwards to infinity. Okay. Remember, you would not say x goes from, let's see, 1/3 x. You wouldn't say it goes from 1/3 x onwards, because you've already taken into consideration the fact that y needs to be less than 1/3 x in this piece here. Okay. Okay. So your final answer, your second bound should not involve a variable. If it does, your final answer will involve a variable. And remember, we're trying to calculate a probability. Probability should be a number between 0 and 1, should not involve a random variable. Okay? All right, we talked more about that in the first video of this series. So if you're interested in that, go back to where I talked about how to integrate this such that total integral equals 1. Okay, so now let me change up this problem a little bit and talk about how we would solve it. Say we wanted to change this to being less than. Okay, so let's change the order and see how that changes things. It actually changes things quite a bit. All right, so actually, instead of erasing all of this, I'm just going to use a different color. Okay, so we still have this line, this red line. Let me use purple now. Okay. But since the direction of this line has changed, we're now upwards. Instead of below this line, we're above this line. All right. And so now we're in this purple area. Okay. How would we integrate over this purple area? Now notice over here, if I want to be above the purple line, I also need to be below this yellow line. So there's no way I can do that. So I will stop here. I don't go below 0, 0. Okay? All right. So now let's see. Where does y, when I'm integrating this, let's do dy dx. All right. So where does y go from? Y goes from 1/3 x all the way up till it gets to the value of x. Then what does x travel from? X goes from 0 to infinity. Okay, so actually integrating this little purple area was a little easier than integrating the red area. All right, let's do another example. Okay, say I want to calculate the probability that x plus y is less than 2. All right, I'll do less than or equal to. The equal to doesn't matter in these cases because they're continuous random variables. So in continuous random variables, the probability of being equal to any number is always 0. So with or without the equality, you get the same answer. Okay, so I'll just mix it up a little bit by having the equality this time. Okay, let me redraw my graph for my support. All right, here is -1. All right. So here is x equals y. So my support is down here. All right. So now I'm in this situation where x plus y, I want it to be less than or equal to 2. So let me go ahead and graph x plus y equals 2. So y then is -x plus 2. Remember, your y equals mx plus b. So let's go ahead and graph this line. M is -1. So, and my slope is, my slope is -1, and my intercept is 2. So here's 2. So I go down 1 over 1, down 1 over 1, down 1 over 1. Okay, I would use a solid line because we have the equality. All right, and so I want to be less than or equal to. So do I shade up here or do I shade down here? Best way to do that is just to use a test point. So I'll go ahead and use the test point 1, 0. Okay, so let's see if I plug in 1 plus 0. Is 1 plus 0 less than 2? Yeah, it is actually. Yeah, 1 is less than 2. Okay, so that means every point in this area where that test point is, it should be shaded. Now respect your boundary of the yellow line as you're doing this. All right, so we have this nice little triangle here. All right. So let's see. If I integrate, so I'm going to want to integrate this. Actually, let me think this through. Should I do it dy dx or dx dy? Now, if I integrate with regards to y first, I change rules halfway through. So I go from -1 until we get to this yellow line, x equals y. This red line is y equals negative x plus y. So I go from -1 to this yellow line, and then I change rules here, and I go from -1 to this red line. So I would have to split up the integral just like I did in the first example. Okay. Now I actually don't have to do it that way. I could do it dx dy, and then I don't have to split up my integral. So actually, it's a little easier in this one to do a dx dy. Now, if you do it the way I just described and you split it up, you should get the same answer, and that'd be a fun little exercise. You should go ahead and try that. Okay. So, but if I do it dx dy, I don't have to split it up, so it's a little bit easier because dx x travels from the yellow line to the red line. Remember, your inside integration has to be the integration that involves the dependent relationship, because you don't want your outer integral to involve x or y, because you want your answer to be between 0 and 1. You don't want it to involve random variables. Okay, so the inner integral for x, if I travel on x first, I go from the yellow line to the red line. So from x equals y, okay, to x equals, now I have to rewrite this with x equals on the other side. So this is the same thing as x equals 2 minus y. Okay, have to rewrite it with regards to x because I'm integrating with regards to x. So from x equals y to x equals 2 minus y. From x equals y to x equals 2 minus y. Okay, so then my outer integral will be the range of y. Let's see, where does y range from? Very interesting, actually. Y does not go from -1 onwards to infinity. It stops here. Y goes from -1 all the way up until +1. Okay, so you could integrate this, and you should get the probability x plus y is less than or equal to 2. All right, now let me switch it up one more time. Let me now say I want to find the probability x plus y is greater than or equal to 2. All right, so still have my two lines I have up here. Okay, except now instead of shading below, I'm going to be shading above. Okay, so let me go ahead and graph these pretty fast. So this is x equals y, and let's see, 1, 2. Okay. And my second line would be down 1 over 1, down 1 over 1. All right, and so now I'm trying to find the integral over this area. Okay, so let's see if I integrate with regards to, again, this one, it's probably easier to integrate with regards to y first, because if I integrate with regards to x first, x is going to change rules halfway through, so I'll have to split it up into two different integrals. Okay, so let's go ahead and integrate with regards to y first. That way I'll have to do one integral. Okay, so y is going to travel from starting down here on this red line. Remember, this red line is y equals -x plus 2. So -x plus 2 all the way till we get to y equals x. okay? And then what is x traveling from? Looks like x is traveling starting at 1 and going onwards to infinity.